Today we're throwing another tool in your tool belt, solving quadratics by completing the square. We are going to try to create one of these types of trinomials where it's a perfect square trinomial, one of our special cases back in the day. So if you look, x squared plus 8x plus 16, in theory if I said factor that, you're thinking of what factors of 16 add up to 8, which would be 4 and 4. So that would give us x plus 4 times x plus 4, which you would write that as x plus 4 squared. We're going to try to create one of those. If you look at this, it's x plus 5 times x plus 5. They would add up to 10, right? And they would multiply 5 times 5 to 25. And that would be x plus 5 squared. So we're creating that perfect square binomial to give us this trinomial. So let's see what we got. We got 9 examples here. We're going to knock them out. So here's the steps to figure out the value of c. The missing value is usually going to be that c. We're going to take our b, in this case it's 14, we're going to divide it by 2, and then we square it. It'll work out. So if I did 14 divided by 2, it's 7. And then 7 squared is 49. That's how we're going to do the process every time. You're going to take the b, divide it by 2, and square it. Now, if that was in factored form, it would just be x plus 7 squared, which we're eventually going to have to write them in that factored form. Super easy to do. If you're doing all this work in the pink, the black step is easy. It's just x, and then whatever you had before you squared it, squared. Let's try another one. So here we're going to take negative 20, we're going to divide it by 2, and then we're going to square it. Negative 20 divided by 2 is negative 10, and then we square it. Negative 10 times negative 10 is positive 100, and then in factored form it would be x, and then whatever we had before we squared it, it was negative 10, so it would be x minus 10 squared. Okay, all right, we're gaining some steam here. Here we're going to take negative 16, we're going to divide it by 2 and square it. Negative 16 divided by 2 is negative 8. Negative 8 times negative 8 is positive 64. Writing that is a perfect square binomial. We'll have x, and then before we squared it was negative 8, so it'd be x minus 8 squared. So you shouldn't have to think, hey, what factors of 64 add up to 16? The pieces are there. They're there, man, they're there. Let's keep it going. Now we're on a roll, dude. We're gonna take the 8, divide by 2, and square it. 8 divided by 2 is 4. 4 squared is 16. Writing that in factored form, x, and it was positive 4. So x plus 4 squared. Here we go. We're taking the 12. We're dividing by 2, and we're squaring it, baby. 12 divided by 2 is 6. 6 times 6 is 36. Writing that as a perfect square, x, and it was positive 6, so x plus 6 squared. Yes! Here we go, negative 40. We're going to take it, divide it by 2, and then square it. Negative 20 squared. Negative 20 times negative 20 is positive 400. Writing that in factored form, x minus 20 squared. Nice. Now these are a little tougher. You could convert these into decimals. We're cooler than that. We're so much cooler. We're going to leave them as fractions. We're going to take 7 divided by 2 and square it. Again, you could make it 3.5. You could square it. No need. Simplify it if you can. We can't. So then when you square a fraction, you square each part. 7 squared is 49 over 2 squared is 4. Whoa! Writing it in factored form, x, and this was positive 7/2 squared. It's not too bad. Here, we're going to take our negative 5, divide it by 2, and then square it. You can't divide negative 5 by 2 unless you want the decimal, negative 2.5. We don't want it, though. We don't want no stinking decimal. So we'll just square it. Negative 5 times negative 5 is positive 25. 2 times 2 is 4. Writing it in factored form, x, and this was negative 5 halves, x minus 5 halves squared. Okay. Let's do one more. Oh boy. 1/2 divided by 2. That's kind of strange. Now, if you think of this kind of as like a side mission here, if we were doing 1/2 divided by 2, it's like divided by 2 over 1. And then you'll keep change flip from back in the day. You change it to multiplication. You flip this fraction upside down. So really, if you had a fraction and you had to divide by 2, you could also multiply by 1 over 2. So this would give us 1/4. And then we're going to square that. Square each part. 1 times 1 is 1. 4 times 4 is 16. Writing that in factored form would be x, and it was positive 1/4 squared. All right, okay. We're cruising now. So this is the first step of solving them by completing the square. And then it becomes like one of those problems that we had back in the day. So here's what I would recommend. You got to get it down to just x squared and the x on one side. You got to send everything else. So in this case, I'd have to get rid of this minus 11. Pretty easy. Just add the 11 to the other side. But here's how I want you to write this. I want you to write x squared plus 10x. And then I like actually putting like a blank here. I put it in the form of a box, or you could just leave space if you want. On the other side, we have 11, and we're also going to put plus box. So we can add whatever we want to both sides. As long as we're doing it to both sides, it keeps it balanced. Plus 30, fine. But we want to put a specific number in that box because we want to create that perfect square that we just practiced for 9 problems straight. So this is where we take the b, the 10 in this case, we divide it by 2, and then we square it. Now 10 divided by 2 is 5. 5 squared is 25. That's the number we're going to put in the box on both sides. And here's why. Because that will allow us to factor the left side into x plus 5 squared. Look at that. That's the whole reason we did it. Now the right side, 11 plus 25 is 36. At this point, then this is like an old problem. We're getting rid of the squared, so we square root. And then remember, we set up 2 problems here, because the square root of 36 could be 6, but it can also be negative 6. So we say x plus 5 equals 6, and x plus 5 equals negative 6. We solve these, and we're good to go. Minus 5 minus 5, minus 5 minus 5. 6 minus 5 is 1. Cool. Negative 6 minus 5 is negative 11. These are both answers to the original problem, and they both work. You can check them both. If you don't believe me, come talk to me in class, and we can check these both together. I assure you they both work. So those are the steps. Let's try it again. What do you say? What do you say? All right. We got to get it down to where it's just x squared and 8x. The minus 9, we got to send it. We're going to add the 9 to the other side. So I'm going to say x squared plus 8x plus blank, going to leave some space here, equals, on the other side we have 9 and then plus blank. Okay, again, we did it over there. We're going to take our b, which is 8, we're going to divide it by 2, and square it to create that perfect square trinomial. 8 divided by 2 is 4. 4 squared is 16. That's the number in the box. What's in the box? So the left side of this equation would factor to x plus 4 squared. The right side is just 9 plus 16, which is 25. Now that we've isolated what's being squared, we can square root it to cancel it out. The square root of 25 could be 5 or negative 5. X plus 4 equals 5, and x plus 4 equals negative 5. And now we just get rid of the plus 4 by subtracting 4 from both sides. 5 minus 4 is 1. Negative 5 minus 4 is negative 9. All right. Looks like we got a couple more here. All right, here we go. We got to get it to where it's just x squared and the minus 6x. So we're going to subtract the 12 first. And we're going to leave some space. X squared minus 6x plus blank. 19 minus 12 is 7 plus blank. We'll take our b, which is negative 6 in this case. We'll divide it by 2, and we'll square it. Negative 6 divided by 2 is negative 3. Negative 3 squared is positive 9. Positive 9, positive 9. By doing that, we can factor the left side into x minus 3 squared. The right side, 7 plus 9 is 16. Cancel out a square by square rooting. Square root of 16 is 4 and negative 4. So x minus 3 equals 4. X minus 3 is negative 4. And now we just add 3 to all sides here. X equals 7. X equals negative 1. All right, here we go. Now, this works when you have 1x squared. The problem with this one is we have 2x squared. Oh, we should just give up on this one then. No, come on, easy fix. We could make it 1x squared. We would just have to divide everything by 2. So we're going to do that. And we'll do it right away to handle that. As long as we're dividing everything by 2, it keeps the balance equation. So that would give us x squared plus 6x plus 2 equals 5. Now it's like the old ones. So we're going to subtract the 2 to get that out of there. So we'll have x squared plus 6x plus blank. 5 minus 2 is 3 plus blank. We're taking our b, which is 6. We're dividing by 2 and we're squaring it. 6 divided by 2 is 3. 3 squared is 9, so plus 9 on both sides. All right, left side would factor to x plus 3 squared. Right side, 3 plus 9 is 12. We'll square root both sides. Now, 12 is not a perfect square. In the future, we're going to learn how to simplify that radical, but for now, we're just going to take the decimal. Let's see, the square root of 12 is 3.46 if we round it. So we could say x plus 3 equals positive 3.46, and x plus 3 equals negative 3.46. Subtract 3, subtract 3. 3.46 minus 3 is 1.46. Negative 3.46 minus 3 is negative 6.46. Look at us completing the square and having some fun today. That was fun.